two sources of equal EMF are connected to an external resistance R. The internal resistance of two sources are R1 and R2, where R2 is greater than R1. That means one of the cell has a more internal resistance than the other. If the potential difference across the sources having internal resistance R2 is 0, then so there are two sources which are of same EMF, equal EMF, and they are connected together. I'll write first one is E1 or E, internal resistance is R1. One more is E, internal resistance R2. Now R2 is greater, it's already given, R2 greater than R1. So second cell is having more internal resistance. Potential difference across the source having internal resistance R2 is 0. So here the potential difference is equal to 0. So what is the relation between R1 and R2? When we connect them to external resistance R. Fine, we have external resistance R connected across this. First of all, we find the current in the circuit. We know current I is equal to, these two cells are in series, EMF is 2E divided by R plus R1 plus R2. Internal resistance will be added, R1 plus R2. So this is the current. And if you want to find the terminal potential difference across one of the cell whose internal resistance R2, we'll find a V. V is equal to EMF across that E minus I into R2. That is E minus I into R2 into I. I is equal to 2E divided by R plus R1 plus R2. And the problem says that is equal to 0, equate to 0. So therefore E is equal to, implies E is equal to R2 2E denominator R plus R1 plus R2. Now E cancels, implies R plus R1 plus R2 is equal to 2 times R2. We require a value of R, so therefore retain R here. It is a R2 goes other side, 2 R2 minus R2, that is R2 minus R1. So therefore R is equal to R2 minus R1, and therefore is given as option B.